All right, let's talk about C programming. There are a couple of concepts that really separate folks who are just starting out from those who are truly in control of their code. I'm talking about pointers and structures. Now, I know they can sound a little scary, but honestly, mastering them is the key to unlocking what C is all about: total control over your computer's memory. And today, we're going to pull back the curtain and make it all make sense. So before we even type a single line of code, let's just stop and think for a second. When you create a variable, where does it go? How on earth does your computer juggle millions, even billions of pieces of data without just, well, completely losing its mind? Turns out it's not magic at all. It's a system, a very organized one. And we're about to get a map. I want you to picture your computer's memory as a massive, sprawling city. Think of it like a metropolis. Every single variable, every piece of data you create is a building somewhere in this city. And just like any city, to find anything specific, you're going to need a map, or even better, a GPS address. And that, right there, brings us to our first huge topic: pointers. See, if our memory is the city, then pointers are our GPS. They don't actually hold the stuff inside the buildings. Nope. They hold the one thing that is absolutely essential: the location, the address. So what is a pointer, really? Well, it's a special kind of variable. Most variables, they hold data, a number like 10 or a letter like A. But a pointer, its one and only job is to hold the memory address of another variable. It's basically just a signpost, pointing you exactly where you need to go. Let's make this super simple with a house address analogy. Imagine your variable, say int x, is a house. Simple enough. The value inside it, maybe the number 10, that's the person living inside the house. Now, every house has a unique street address, right? That's the memory address. So what's the pointer? The pointer is nothing more than a little piece of paper where you've scribbled down that street address so you never forget how to get back to that house. Okay, so how do we actually use this address we've written down? Well, with direct access, you just use the variable's name. That's like you already know the house. You walk up and you knock on the door. But with a pointer, you use indirect access. And that little asterisk, the star, that is the magic key. It's the command that tells the computer, hey, don't just read me the address on this piece of paper. I want you to actually go to that address and tell me what's inside the house. Okay, we've got our GPS system for finding all the houses in our memory city. That's great. But what if we want to build something a little more complex than just a simple house? What if we need, I don't know, a library or a huge office building with different kinds of routes? Well, that's where structures come into play. They are the custom blueprints for our city. Now, you might be thinking, hold on, don't we already have arrays for grouping data together? And yeah, you're totally right. But think of arrays like a street in the suburbs, lined with identical cookie-cutter houses. They all have to be the same data type. A structure, on the other hand, is like a custom-designed skyscraper. It can have all sorts of different things under one roof. Maybe some text for a name, a number for an ID, and a decimal for a grade, all bundled neatly together in one package. And here's what one of those blueprints actually looks like in the code. We're designing a student building here. Our struct blueprint says that every single student building we create will have 3 distinct rooms inside: a space for a name, a spot for an ID number, and another for a CGPA. What we've really done here is we've invented our own custom data type. How cool is that? So you've built your awesome student structure, your new building. How do you get into the different rooms? Easy. You use the dot operator. Just think of the dot as the key. When you write s1.id, you're saying, go to the building named S1 and unlock the room labeled ID. It's a super direct, super simple way to get to all the individual pieces inside. So we've got our GPS system with pointers, and we have our custom blueprints with structures. Now, on their own, they're both pretty useful. But when you combine them, oh man, that is when C programming becomes an absolute powerhouse. So let's do it. Let's put it all together. To really get why this combo is such a game changer, you have to understand how functions get data. By default, C passes by value. What that means is if you give data to a function, you're really just handing it a photocopy. The function can scribble all over that copy, but your original piece of paper is untouched. But when you pass a pointer, you're passing by reference. You aren't sending a copy anymore. You are handing over the original home address. You're giving that function the key to the actual house, letting it go inside and make changes that stick. All right, enough with the analogies for a minute. Let's get our hands dirty with a real-world example, something straight out of engineering. We're going to model an electrical component, a resistor, using these exact tools. This is precisely how you'd use structures to represent actual physical objects in a complex system. And we can do it in 3 really simple logical steps. First, we define our blueprint with struct resistor. This will hold all the specs we need. Second, we actually manufacture one. We declare R1. This creates our component, building in memory. And third, we create our pointer, PTR, and we tell it to store the address of R1. Just like that, we have a way to find our component from anywhere in our program. Now, you could use the star and the dot together, something like &R pointer dot resistance, but it just looks a little clumsy, right? Well, C gives us this beautiful little shortcut for this exact situation, the arrow operator. It basically squishes go to this address and get this specific thing into one clean, super readable symbol. So here's the golden rule, the one thing you really need to remember. If you have the structure variable itself, you use a dot. If you have a pointer to that structure, you use an arrow. That's it. PTR.resistance is just the clean, professional way to say, follow this pointer and get me the resistance value. You're going to see this everywhere in C code. And there you have it. Pointers are your GPS, structures are your blueprints, and when you put them together, you get the power to build and manage an entire city of data. This direct line to memory is what makes C so ridiculously fast and powerful. But, and this is a big but, with that power comes a lot of responsibility. Because if your pointer, your GPS, is pointing to the wrong address, you won't just be lost, you could bring a whole city block crashing down. So use your new keys wisely.